we're still in the same lesson of principal moments, and this little video is about examples of solving problems. Okay, it's a little bit of a long lesson, so 2 videos. So this, the question I can give you in a test, they all look like this. Now I'm going to say that the maths behind them is a bit difficult, in my opinion, but well, not that difficult. But I think it's quite complex problems. But I find that students, you guys are quite good in this. In this principal moments, because you have, and the reason I think is that you have good intuition. You've been on a seesaw, so you know how it works. Okay, so we've got an object that pushes this seesaw 2 newtons, and it's 2 meters away from the pivot. And we've got another object. We don't know the weight, the force that pushes the seesaw, but we know it's 1.5 meters. Okay, and the question is, what's the force? Okay. So what I'm going to do is, first of all, calculate the anti-clockwise moment. These are the anti-clockwise moment. I normally, instead of writing ACW, I just write that turn. I know that it's turning it this way. And I will say, okay, that's going to be 1.5 F. Okay? And I don't know what F is. Okay? Just a second, guys. Okay, so that's the anti-clockwise moments. Now, on the other hand, the clockwise moments, okay, that's going to be the force, 2 Newton, time 2 meters. So that I know is 4 Newton meters. So on the one hand, I know the clockwise moment is 4 Newton meters, and the anti-clockwise is 1.5 F, which I don't know how much it's equal to, because I don't know what F is. But what do I know about these 2 moments? If I tell you, and by the way, I didn't say, in the test I will obviously say, the seesaw is balanced. In other words, there is rotational equilibrium. So in that case, I know that the anti-clockwise moment must be equal to each other. The clockwise and anti-clockwise must be equal to each other. So I'm going to write 1.5 F equal 4. And then I'm going to write F equal 4 divided 1.5. And I'll use the calculator. Let's just get that. Okay, so I'm going to write 4 divided by 1.5. And often we'll have numbers that are not whole. And the answer is 2.67. Okay? Because we work with newtons and meters on both sides, the answer will be in newtons. Okay? Let's do another one. Okay, I've done actually a very similar question. I changed that to 10 Newton. Okay? Keep that as 1.5 meters. We still don't know what the force, and we want to calculate the force. But one change I did is the distance here is not 2 meters, it's 200 centimeters. Okay? And I think you can already figure out what's the problem here. Okay, the problem is I've got 1.5 meters and 250 centimeters. I'm not using the same units. I have to use the same units. Okay? So the clockwise moments is going to be 10 Newton time. Because this is in meters, I might as well convert that to meters as well. So time 2.5 meters, and that's 25 Newton meters. You can use a calculator, but honestly, time by 10, just move this decimal place. Right, okay? We have to work with the same unit, so I have to convert that to meters. Okay? On the other hand, okay, clockwise moments. The clockwise moments are still going to be 1.5 F. I didn't really change anything here. Okay? In the test scenario, by the way, you'll get 1 mark for converting that to meters, probably 1 more mark for calculating these 2, and then the 3rd mark to make sure, I want to see that you understand for equilibrium, for rotational balance, so it will be balanced, I need to make sure that these are equal. How do I do that? I say 1.5 F equal 25 Newton meters. Okay? So if you've done that in a test, I'll give an extra mark. So that's 3 marks so far. Okay? Then, get rid of the 1.5, just count dividing the 25 by 1.5. Using the calculator, 25 divided by 1.5 equal 16.67. 16.67 Newton. Okay? So that's one variation I can put to that problem. A little twist, change of units. Let's do another kind. Okay, the second kind of problem I can do is give you weights of both. I'll give you the force on either side. Okay, but give you the distance only on one side. But it's exactly the same thing. We'll start by calculating the clockwise moment. The clockwise moments is going to be 2 meters times 5 Newton, or 5 Newton times 2 meters, the same. And we get 10 Newton meters. On the anti-clockwise side, okay, the anti-clockwise moment, that's going to be 8 Newton times this distance. I don't know what that distance, I might as well give it the letter x. So it's going to be 8x, okay? 8 Newton times x, 8x. Right, so I got 1 mark on either side. Now, third mark is if I understand for rotational balance, these two numbers need to be the same. So I demand, say 8x equal 10. Okay? And that means 10 equal 10, 8x equal 10. So x equal 10 divided by 8, which is 5 divided by 4, which is 1.25, I think. But let's just make sure. 10 divided by 8 equal 1.25. So the answer is 1.25. Because with our work in newtons and meters, the answer will be in meters. Okay? So voila, I got the answer. Now I'll do one more tricky question. Okay, so sometimes there might be more than one force on either side. Okay? So there will be more than one moment, more than one clockwise moment, more than one anti-clockwise moment. So what you have to understand, this is what the word sum, I think when I told you about the principal moment, is that the sum of clockwise moment equal to the sum of anti-clockwise moment. In other words, there might be more than one clockwise moment. We need to add them together. So let's say we have this swing, and we've got 5 Newton 1 meter away, 50 Newton 2 meters on the other side, and we've got one more force, which I don't know what it is, which is 1 meter away from the 5 Newton. It's not 1 meter away from the pivot, and we'll have to figure out how much that is, but it's 1 meter further back. And I need to calculate this force to have a rotational equilibrium. Let's start by calculating the moment, the anti-clockwise moment. This is the anti-clockwise, alright, like this here, okay? So the anti-clockwise moment will be 50 Newton times 2, which is equal to 30 Newton meters. Now before I do that, okay, I think if I ask you in the class, what should be the force? What should be the force to have rotational equilibrium? Some of you guys, there will be not a lot, but maybe a few people will say, oh, no problem, so it's going to be 10 Newton. Okay? Now, why? And that's wrong. It's not necessarily 10 Newton. It might be, but that's just a coincidence. I don't think it will be. But why would some people say 10 Newton? I would guess is that they look, there's 50 Newton on this side, there's 5 Newton on this side, so there must be another 10 to balance it. But we know it's wrong. Okay, because the rotational equilibrium, okay, doesn't come up when the forces are the same. It doesn't come up when the distances are the same. It comes up when the moments are the same. So that can't, not necessarily 10 Newton. What needs to be the same is the same moments. So this is the anti-clockwise moments. Now let's calculate the clockwise moments. Now the clockwise moments are sum of the clockwise moment made out from the moment from this force and the moment from that force. Both these forces, look at this, both these forces are pressing this seesaw to move in the clockwise moment. So we need to add both of them. Okay, right, what will be the moment from the 5 Newton? The moment from the 5 Newton will be 5 Newton times 1 meter. That's easy. What will be the moment that this force creates? Well, it's going to be F, which I don't know how much F is, time the distance from the pivot. What is the distance from the pivot? Don't write 1 meter. It's not 1 meter because this is just 1 meter from here. The distance to the pivot is 1 plus 1 is 2. Okay? And notice here that I put the plus because the total anti-clockwise moment is equal to the sum of these moments. The moments from this force and the moments from that force. They're both making that seesaw move in the clockwise motion. Okay? So the answer will be 5 plus 2a. Okay? Now, what do I know about both clockwise moments and anti-clockwise moments? I know that to have a rotational equilibrium, they must be the same. So I'm going to say 30 Newton meter equal 5 plus 2f. I want to find out the force. So I'm going to get rid of the 5. I'll do minus 5. So 2f equal 25. Get rid of the 2 by dividing by 2. F equal 12.5. Because I work in newtons and meters, the answer will be newtons. And so that is a difficult level question. Right, I'll put some questions, similar questions for you underneath in the worksheet, or we'll find a way. I want you to work on that, and then until the next lesson. Bye-bye, guys.